Okay. It's my pleasure to introduce today Jon Kleinberg. I'll keep the introduction short since he really needs no introduction, and we want to hear as much as what he has to say as possible in our limited time. But as I'm sure you're all aware, Jon has won most every imaginable prize under the sun, including the ACM-Infosys Award, the Nevanlinna Prize, MacArthur Genius Grant, Sloan Grant, and several others. He's written 2 stellar textbooks that most of us are aware of, one in algorithm design and one on networks, crowds, and markets. He works at the intersection of computer science and most anything else he can get his hands on. So we're pleased to introduce today Jon Kleinberg. Thank you.
Thanks. Thanks. Yeah, thanks very much for the invitation to come speak here. And very nice to get a chance to come by the computer science department, meet a bunch of people who I know, and meet some new people also. So what I wanted to talk about was some work we've been doing, including some very recent work that'll be appearing at the World Wide Web Conference in May, looking at the role of incentives in guiding actions on websites where people are producing and sharing content. Okay, so there's been this gigantic movement online, obviously, toward basically the voluntary production of new content, answering each other's questions. Also, voluntary effort toward enriching oneself, right, through things like the Khan Academy and online courses, right? So I'm thinking about all of these, right? On Wikipedia, people are taking what they know and they're sharing it with the world. On Khan Academy, they're spending time setting goals for themselves without any real organizing apparatus around it. Stack Overflow is one of many examples of a question answering site where people come with questions, other people come and share their expertise, and there's kind of a matching of questioners and answerers. And right, so all of this has led to a lot of discussion about what is it that's motivating people to really take part in this, and how do we optimally create incentives that steer people toward the right kinds of activities in these domains. How do we motivate activity? How do we recognize contributions? And all of this is a constellation of questions that I think several different communities are coming together to ask, and using a number of different approaches, right? So I've enumerated some of the things people have thought about here. So on the one hand, we have things like social psychological questions about why do people engage with social media? What sort of implicit rewards do people get? And a lot of work has established that there is a notion of reward happening here, right? That people are clearly deriving value from their participation in these sites. And that's now a kind of value that we could use to think about in incentives, right? So for example, my colleague Arpita Ghosh at Cornell with Preston McAfee, who's now at Google, has thought about questions like mechanisms to encourage quality contributions, right? So how to create incentives that encourage higher quality content rather than lower quality. Other people have looked at, for example, crowdsourcing contests, right? So think about your contribution as sort of almost an all-pay auction in which your effort has value and you're contributing that value in the hope that you'll achieve recognition or other kinds of rewards. And then there are other things, right? How do you recruit new people to these systems, and the creation of a lot of ad hoc or on-the-fly mechanisms where I go out and I try to reach out broadly into the community and pull in new members through kind of distributed mechanisms. Okay, so there's a whole bunch of things that people have looked at. I want to talk about work that began, and this is going to be joint work with Jure Leskovec at Stanford, my colleague Dan Huttenlocher at Cornell, and Jure's student Ashton Anderson. And the four of us were interested in a particular kind of mechanism that's been in use here, right? So in comparison with some of these other things which are relatively complicated, which are involve some amount of intricacy, there's a very simple thing that lots and lots of websites are using, which is badges, right? So they set milestones, and they say if you achieve a certain amount of stuff, or if you do a certain set of things, we'll confer a badge on you, right? And that badge is now how we've encapsulated the value, right? So a very primitive sort of mechanism in one sense, but as we'll see, even this primitive mechanism, or maybe because of its primitiveness, induces relatively complex behaviors on the population, right? So where are badges in use? So Foursquare is one place that's certainly popularized the use of badges. And there's a wide range of badges, right? So here are some that reward cumulative effort, right? So many websites have a badge for your first action on the site to reward you for showing up, to make you feel engaged. And then, checking into 10 different places, 25 different, and so forth, right? Foursquare being a site that's about registering your location to places and doing that in a social way so your friends see where you've been. And there's a whole variety of interesting badges On Foursquare, if in at least 4 occasions you've checked into a hotel between 1 a.m. and 4 a.m., right, you're a late night check-in kind of person, right? All these things indicate sort of different aspects of your behavior. And when there are new events, right, when there's an event like South by Southwest going on now, new badges get created that are specific to that event. A second example, which I'll actually spend a fair amount of time talking about, is the question answering site Stack Overflow, which has a wide variety of badges, and we'll be talking about some of those that are essentially there to reward activity like answering people's questions, editing posts, upvoting and downvoting and rating content. All of these are things that they want to incentivize, and therefore they create badges for them. Stack Overflow has different grades of badges. There are bronze badges, silver badges, and gold badges. The gold badges are sort of particularly hard to get. I'll be talking about the effect of one gold badge that got introduced later on. Actually, the gold badges are cherished enough that someone did this nice thing. They got a kind of a industrial strength sewing machine and made a bunch of physical gold badges that you could sew onto your clothing. And it came with this warning that if you see someone wearing this badge, it's your duty to ask them how they earned it. And if you can't answer that, you're standing face to face with evil that didn't earn the badge and has no right to be wearing it. Right? So people feel very strongly about these hard to get badges. And out of the roughly 500,000 people who get the newcomer badge on Stack Overflow because they've registered an action that sort of hits that threshold, some of these badges only go to order of a few hundreds of people. Right? Okay, now of course, badges, the idea of using badges is inherited from the offline world, right, where we have badges in many, many different domains. I mean, some places we have physical badges, like in the Boy Scouts. And when Ashton, Jure student, was working on this paper, he went out and dusted off a shoebox that had real live badges for, doing things like starting fires in the woods and the stuff that Boy Scouts are known for. But there are also grades of achievement in many domains. One that many of us are familiar with is in academia. You work and then you achieve certain badges. And actually, this connection with academia is one that I have found intriguing for a while. And at the end of the talk, if there's a bit of time, I'll talk about how some of this connects, I think, in some ways to phenomena that happen in the allocation of credit in academia and within the scientific community. Okay, so badges. So they do a bunch of things. Here are some more badges. These are from the Khan Academy, ranging from like moon badges to sun badges, which are epic, and black hole badges, which are legendary. Right, and the same sort of context gets built up around all of them, right? So they sort of do various things. So first of all, you can get badges as in these illustrations for several things. You can get them for cumulative effort. You've done many things. When you've finally done enough things, you get the badge. Or sometimes they're for doing a single great thing. Right, so like on Stack Overflow, if you asked, if you provide an answer that got upvoted at least, a certain number of 100 times, then you had a great answer, and that gives you the great answer badge. And that's a thing you did once in your life, and now you've got the badge. Right? So they can reward either of those, effort over a sustained period or one-time great achievements. And they clearly have these sort of dual roles, right? So on the one hand, it's a credential. And arguably, when they were first introduced, I think the credentialing aspect was maybe what was in the forefront of people's thinking, that it's there to show that you have a certain expertise. You've done this thing, and now we can recognize that. But it quickly became clear that it was functioning as this sort of powerful form of incentive. The people wanted these badges, and they would alter their behavior to try gain them, which is going to be the issue that we much more want to explore. Okay, how do these badges produce feedback effects that people are then going to use to guide behavior? So. Right, so incentive aspects and cumulative effort. That's going to be sort of the part of the space that we're going to think about when we talk about badges. Obviously, there's sort of part of this broad issue of gamification of websites, right? Taking things that we know or believe work well in computer games, the idea of advancing through levels, reaching milestones, and sort of applying that to many other kinds of websites, right? To things like check-in services like Foursquare, to contribution sites like Stack Overflow. It's also, if you think about it, there's a bit of literature in the world of marketing on customer loyalty programs, right? Because yet one more form of badge is something like silver elite status or gold elite status on an airline is a badge that you earn, which again confers some kind of benefits, right? I see some disagreement that this is not it. So, I don't know. I would say if we think broadly of these things as milestones that recognize some level of effort and that produce incentives, I would put them in that category. But happy to discuss the contrast.
Well, I guess I don't know if you're actually soliciting questions, but the loyalty things have explicit cash tie-ins, A and B. You don't post them on your website with frequent flyer clubs you're in, and so it's neither of its prestige social thing, nor is it a substitute for financial incentives. It's just a vehicle for providing financial incentives. I thought interesting. I thought you were going to focus on using these in the absence of financial incentives.
So it is true that the ones I'll be talking about are in the absence of financial incentives, but for example, on these sites, right, if you're thinking about these sites, some of the badges do confer concrete benefits, right? If you're the owner of this badge, you have access to certain things in the way that if you have loyalty status on an airline, you have access to certain things within the system. But I agree. One big difference is that loyalty programs are tied up with you spending actual money, and these aren't. So if we take money as a top-level distinction, then I agree with that distinction. But I think in the sense of it gives you power within the site because it's a milestone you achieve, then yeah. But so the interesting thing is that one thing with badges is, so first of all, they tend to be simple for users to understand, right? So as opposed to more complicated systems, it says if you do the following, you will get a badge, and somehow that clearly is something people understand. If you look at the discussion forums on all these sites, there's lots of discussion about how to reach various badge levels and what to do. It's also somehow not like a leaderboard, and it's less based on competition with others, right? It's your personal milestone that you're trying to reach. Certainly some badges are rarer, but that's because it's harder to get to that level, but not because other people outcompeted you for it. Okay, so it has all those properties. Okay, so I want to, as an example of how some of this works, we can think about sort of what kind of badges you actually see on Stack Overflow. And because I'll be talking about Stack Overflow as the main data source that we'll be looking at, I sort of wanted to work through this. So this is an example of a page on Stack Overflow for those of you who haven't used it before. It consists of questions that have titles. This is one about how to compute connecting components in a graph with 100 million nodes. And someone tells some story about what they're trying to do, and here's what worked and what didn't. That's the question. And then there's answers down here. And so sort of 4 features I want you to notice about Stack Overflow, because we'll be talking about them a lot, is there's a question, there's a sequence of answers. I showed you the first one. It goes down. You can vote on whether you think this is a good question. And what that's useful for is if I'm scanning the site and trying to find interesting things to look at, I look for things that got a lot of upvotes, because that might be interesting content. And so the system wants people to be providing votes because it wants to be able to, users to be able to recognize what's good content. And then, maybe even more important, you want votes on the answers. Right? And so I have a sequence of answers. They get votes, and the ones with the higher votes get moved up toward the top. Right? And this kind of upvoting mechanism is also very powerful, because then somehow people are free to contribute whatever uninformed or pointless answers they want, but if they don't get upvoted, they end up toward the bottom of the list, and they're somehow less interfering with the whole site. Okay, so questions, answers, votes on questions, votes on answers. Sort of maybe 4 basic categories of actions that people take on the site. Okay, and so we'll be talking about badges in general, but think about the Stack Overflow motivation, where there are going to be badges for, have you asked, a bunch of questions or answers, have you voted a lot? All these are milestones in each of these actions that you could try achieving. Okay, so here are some of the questions I would like to understand. One is, I set up a criterion for a badge, right? So you have some behavior you would like to pursue on the site in your sort of natural state if there were no badges. I put up badges, and I want to imagine the badges as creating sort of force fields that start sort of steering your behavior, right? You were sort of heading this way in what you were doing, but I introduce the badge and I begin steering some other way. And I want to understand sort of, can I reason about how that effect works? And do I even see the evidence of that on a site like Stack Overflow? Do I actually see that a force field got set up and suddenly you're steering? And then the second is, if we believe that actually happens, and I'll try to offer some evidence that something like that is happening, then badge placement becomes an actual design problem. It becomes almost like a kind of facility location problem. It says, I have some number of badges. I'm going to try to place them cleverly on the site to try creating a force field that steers people to do what I want. So for example, if I feel that not enough people are upvoting questions on Stack Overflow, I could introduce a badge that tries to steer people that way, right? If I feel that not enough people are going back and editing old posts, I put up a badge for that and I try to steer people to it. So as a site designer, I'm truly trying to solve a placement problem. I'm trying to allocate these badges. Okay, so that's kind of going to be the basic setup, right? So we're going to assume badges have value, although I'll come back to this question of what badges derive their value from. And I'll mention up front that that's, I think, an interesting open question lurking in all this, right? What is the actual mechanism by which the badges are providing value, right? Here we'll sort of posit that there's value, but that's a good question to come back to. Then a user is going to have a preferred mix of activities, what they would sort of naturally do, and then the goal of achieving the badge. And so now they get this kind of mixed optimization problem where both of those figure in the objective function. And what we'd like to do is sort of see how does this steer people through the site. Also, how does it increase engagement? Right? And I sort of want to think of increased engagement on the site as yet one more form of steering. Right? So if I go back to Stack Overflow, we can imagine conceptually that instead of 4 actions, I can ask a question, answer, I can vote, questions and vote and answers, there's a 5th action, which is you could get on with the rest of your life, right? And not use Stack Overflow. Right? And we'll actually try to explicitly think about that as that's sort of like the life action, right? And so that too is a form of steering, as in if I increase engagement, I'm causing you to sort of offload time from the rest of your life onto the site. If I decrease engagement, I'm offloading from the site onto, So obviously, site versus non-site is one distinction that's different from do I decide to ask a question or do I decide to pose an answer. But we'll at least start with a framework that puts all of those together. Okay. All right. So what's the framework? So here's kind of the basic picture, and I want to spend sort of some amount of time staring at pictures like this, because what this is sort of the space of types of actions you can do and some sort of table showing how much you've done so far. Okay. So we imagine an abstract site, and later we'll come back and try to map this onto Stack Overflow, where it actually maps reasonably closely, and it maps pretty well onto other kinds of sites, onto things like Coursera, where people have forums and they do units and they reach milestones. To some extent, things like Foursquare, though the badges are much more diverse there. So I have action types. I have A1, A2, up to AN+1, things like this. And I'll say AN+1 is reserved as, again, what I'll call the life action. So if you want to think about, how about engagement, we'll think about that as, but at this abstract level, we just have a bunch of actions you can do. Now, what is it that you want to do? And here we wrestled with different modeling decisions, and I'm going to tell you the one we arrived at, because it somehow seems to work, it's much less brittle than the other choices, which is what you actually have for actions. It's not that at any given moment there's a thing you fixed, this is a fixed thing you want to do. What you have is a preferred distribution, P. It could be varying with how much you've done. I'll think of it as constant for now. That doesn't really matter. But the point is it's a distribution. And so at every step, what you're going to do is sample from that distribution. So maybe what I like doing is, answering questions 80% of the time and asking questions 20% of the time. And so that says when I get to a given state, I'm going to flip a coin with that bias. I'm going to pull from it. And I want that actual distribution because somehow it produces sort of a much smoother model than if I say at a given point I deterministically want to do one thing or another, right? If I try doing that, then if I study you as you move through the space, you get these very bizarre rectilinear paths where I feel like doing this for a while and I feel like doing that. It doesn't seem to capture the actual mix of activities. So that's just a decision we're going to have a distribution you select from. Okay. So that sort of describes the trajectory through here, right? You start as a newbie. You've done nothing of action type 1 or 2. And you're at 0. And then as you've done actions, this person, for example, has done 6 actions of type 1, 3 actions of type 2. And they're going to sample from this distribution. And maybe this is P, so it has a heavy weight this way, and it's less likely to go that way. So what they're doing is a random upward walk through this, because that's their preferred mix of actions. Right? So that's people in their organic state. It defines this walk that's escaping out to infinity. And I want to cut this walk off somewhere. So there's going to be some probability that you just exit the system with some little probability delta. Right? Because you used to be a heavy Stack Overflow user, but then you changed jobs to a more interesting job, and you're busy now, and so you don't have time for Stack Overflow, and you've left the system. And I'm going to think of that as sort of an exogenous reason, like you changed jobs, and it wasn't that you necessarily planned to stop on that date, but you did. Okay? It could also be maybe your prediction that, because later we'll see that you're working toward badges, maybe it's simply your prediction that one day you'll wake up in this badge that you've been working toward for 8 months. They say, good news, users, we've reconfigured our badges, and here's the new set of badges, right? And all that work goes down the drain. So there's some chance that you'll wake up tomorrow and this thing you were trying to get is gone, right? Either because you don't use the site or whatever. So, okay. So now the random walk says it's sort of up and to the right, and coins get flipped, and at some probability you exit the system. So now there really is some well-defined stationary distribution over this. Right? I send out all these random particles, and they evaporate, and I get some skew-ins. Okay. So I want you to think about that as the system in its natural state. And a 2D picture is fine here. Yeah?
Do you consider any kind of pulling force towards the badge, that is the distance from the final? Okay.
We'll get to that. So far there are no badges. So think of this as all the little iron filings all spilling out, and I haven't put up the magnetic plates yet to try getting to do stuff. Okay. So, good. So, all right, we want to put badges into this picture. So a badge is simply a predicate on your set of actions. Because remember, these are cumulative badges. I'm not here going to try to handle the you provided a great answer that got 100 votes. That's a good question. That's not what we're doing. We're doing cumulative rewards, which many of these badges are. So I have some predicate on the current action. So maybe the blue badge says, I'm going to reward you once you have done at least 10 actions of type 1. You've crossed the blue threshold. This one will reward you when you've done at least 5 actions of type 2. And of course, I could have slanted badges. I could have weird-looking badges, all sorts of stuff. OK, so I have some indicator function for the badge. And so I have an action vector A, which is some point here on this integer lattice. And the indicator function is 1 if the user has earned the badge. I'm going to consider monotone badges, badges that you can't lose by doing more. Right? So that says, if You've got the badge here, and this coordinate-wise dominates that one. This is going to be a useful piece of vector notation I'm going to use. So this A tilde is at least as big in every coordinate as that one. Then you also get the badge. Right? And almost anything you would draw that's sort of sensible is monotone. That's not a big problem. OK, so yeah, so this gets to your question about, OK, so now I'm starting to set up the charge plates. The plates are there. I haven't really put charge into them yet. OK, so finally, what utility does a user get from this? OK, so here's going to be what a user is roughly trying to do as they steer through this space in the presence of badges. So there are going to be two parts. One is there's going to be a value for each badge the user has earned. Right, so B comes with a value VB. And again, remember, I'm going to take value for now as just primitive. Badges have value. We just declared that. Secondly, I have to say something about how you would prefer to do your preferred mix of actions. Right? All else being equal, that's what you'd like to do. So there should be a cost if you choose some other distribution. And that's now going to be the optimization problem. I have to choose what kind of distribution I want over actions at any point in time, balancing between my interest in doing what I would normally want to do and my interest in receiving the badge. Okay? So this becomes the following kind of optimization problem. So I'll walk through this. There's a big, long formula, which I'm going to argue encodes something that's intuitively sensible. So let's see what it does. Right? This is basically trying to encode, I would like to keep to what I normally want to do. I also want to get the badge. But I realize the badge might go away. So, OK, so I'm going to choose a distribution here. And my utility for that distribution is going to be the following. It's going to depend on my choices I make later on. So first, I derive value from having this badge. And let's imagine I derive value each and every day from having that badge. So that persists no matter where I am. Take each of the badges I have, and I have that value. OK. Second, there's a recursive step, which is when I sample from this action, I'm going to end up in a new state. What is this new state? Well, so xa to the I is the ith coordinate of A. And so with probability this, I move in the ith coordinate, and I end up at this vector, A plus the ith unit vector. So now I'm here, where I recursively use whatever distribution I plan to use here, and recursively get some utility from it. So the second thing says I'm really generally going to sample from this, and so with some probability I'll end up here, and I'll get that utility recursively. Of course, I might not live that long, right? I might exit the system, so there's only a probability theta that I still survive to actually do that. Okay. And finally, I pay a penalty because I didn't pick P, I picked X sub A, and there's some cost for doing that. And those are the three terms. Now, for those of you who like Markov decision processes, this you can turn into a Markov decision process. That's actually not going to be directly useful for us because Markov decision processes are computationally hard to analyze even when they're small. And this is one with a countable state set and a continuum of strategies. And so it's sort of not necessarily a useful analogy to make, but it is there for sort of conceptually unpacking what's going on. Right? I'm going to pick a distribution in every single state. It's going to be recursive. I get the value from the badges. I get recursively the value from the state I end up in, where I end up here with this probability. And of course, I have to live that long, and I pay this cost. Any questions about that? Everyone OK? OK. So that's basically the thing that we're going to be studying, right? And that's what the user is. And again, I would argue, this is reflecting sort of a basic trade-off that you certainly, when you look at discussions about badges, you see people discuss exactly, this versus that, which is I'm trying to get this badge, but I'm not doing this other thing, and that's another trade-off we're looking at. Good. OK. So now the question is, how do we solve a problem like this? Right? How do we choose the action in each state? So first of all, the worry is, you say, oh, well, it's recursive, so we'll just do it by induction. Just tell me what the base case is, and we'll be all set. Well, it's a slight problem, because the induction builds this from these two, and this goes on forever. So the induction isn't really well-founded. It just takes off up and to the right. So I have to start the recursion somewhere. So let's build up to that, right? It's a slight move. The thing to think about is, of course, in this case with two badges, once you're past both badges, you know what you're going to do. No more badges. So you're just going to go back to doing what you wanted to do. So there actually is a base case for this thing. And it's this area in the upper right where you're going to do P, your preferred distribution, because there's no more reason to do anything else. So at least that part I've got anchored down. Not quite a good enough base case, because this stuff flees out to infinity that way, and there's no base case for that. So I need to do something a little more careful. All right, so let's think about how we actually figure out what a user is going to do here. So let's start simple, because one badge in a single dimension already has this problem of not being well-founded. So what am I going to do here? So I get a badge with reward VB if I do at least 5 actions of type 2. Actions of type 1, who cares, right? Okay, so now the point is, the way I think about this and the way I solve this optimization problem is to say, if I move to the right, it's actually like self-looping because it doesn't bring me any closer to the badge, right? And so my behavior to the right here should be identical to my behavior here. So this really is a one-dimensional problem where I only care really about this dimension. Okay? And so really this recursion becomes, if I decide to move to the right, it's like I loop back to where I was because there's nothing going on to the right, and so it doesn't really matter where I am. And if I move here, I've made progress, and I only need a finite number of steps to get the badge. Okay? So viewed that way, we see how to actually solve this by induction. We just work, for example, in the first column. We say, once you're up here, you do distribution P, because there are no more badges. And when you're down here, you do something that says, well, if I pick this action, I just stay where I am, and if I pick this action, I move forward. Okay? And from that, I can work backwards and actually figure out what is the optimal solution there. Okay, so that's with very simple badge. Now, even just this one simple badge produces an interesting kind of effect, an effect that we'll actually see once we go look at some data from Stack Overflow. But for now, I'll just show you the effect in the analytical solution. Okay, so if you try this out, so what I'll show you is what is your probability of doing the badge rewarding, the badge favored action at every distance from the badge. Okay, so we created, just for pedagogical purposes, a synthetic instance. Say you get the badge when you do 25 actions of this type. Okay, and we made up a value for P and everything just to be able to show you an example. And so there was your question, Takas, that do you sort of feel the badge getting closer, right? So there's an interesting question, like, you know, in your mind, you do feel like you feel the badge getting closer, but is this optimization problem enough to actually show that it feels the badge getting closer? The answer is actually yes, it does. So here's a case where you reward 25 actions of type 1. Okay, and this is, so your preferred distribution when you start out is 70% on the green action, 20% on the red action, 10% on the blue action. That's what you would like to be doing. The badge has a value of, I forget, something like about 25. Also, here's what's going to happen. So what I'm tracking is the number of actions you've done of type A1 and the optimal probability that you're placing on this. And as you get close, you see this thing ramps up sharply. Right? Because in a sense, when you're far from the badge, the chance that you'll live long enough to get the badge is actually relatively low. And so you shouldn't trade off your preferred everyday life for that long-range badge. As you get closer, that calculation changes. You're actually now reasonably likely to get the badge, and so you start to accelerate. And so one question I'll push on the I was going to say stack, but that would sound like some hideous pun. But you know, one question I'll sort of keep in the background here is, does this actually happen on Stack Overflow? Can we actually see people feel the power of the badge as they get closer? Right? So we'll ask that question in a second. But this is at least the prediction from the model, that you're going to accelerate. Okay, and so this is the sense in which we mean steering, right? By choosing to place the badge somewhere, you're steering actions. Let's also push into the background and come back to, if you're the site designer and you believe this is happening, how far out should you put the badge, right? Because you want to pull people in, but of course, once, you know, if you put it too far, it looks hopeless, even to the optimization function. I mean, forget the human beings. And if you put it too close in, they'll get the badge, and then you'll lose control over them, because they'll do whatever they want, right? So how does that work? Okay. You can do this with other things, right? So let's go back to my original picture. This sort of gives you a recipe once you know how to handle one-dimensional badges. One-dimensional badge is sort of the insight to handle anything else. So what I'll do here is take all the badge boundaries and chop up space according to, you know, you're on the same side of each badge. So I have 4 spaces here. This one we know you're just going to do whatever you feel like. You're going to do distribution P because that's your favorite one, and there are no more badges to get. This now looks like a one-dimensional problem where you're just trying to get there. And this looks like a one-dimensional problem where you're just trying to get there. And we know how to solve those. And then finally, you've got this finite rectangle, which is the last one. But the finite rectangle is finite. And so I can actually do that one by induction. Because this thing gives me a way to do things by induction as long as I can always know what this value and that value is. Okay? So with badges like this, in general, I can chop up space, at least if they're axis-aligned badges. I can chop up space. And I can work from the upper right down to the lower left, knowing the upper right, the very most upper right, is anchored at you just do your preferred action. And then we have some one-dimensional problems. We finally work our way back. Okay, and here too you could ask what happens with the badges. I'll mention a third question to push into the background. I'll come back to. You could ask, that's fine for axis-aligned badges, but is this whole chopping up of space, exactly what does that mean for arbitrary monotone badges. And you should even ask yourself, what do I mean by an arbitrary monotone badge, right? An arbitrary monotone set of action vectors you could do. Is there even a way to talk about that in some sensible way? So I'll come back to that. All right, but this is sort of the next simplest thing. And so the question is, I've set up the charged plates. I want to know, what do the iron filings actually do? The answer is that's what they do, for example, in a typical thing. So I'm rewarding 15 actions here, 15 actions here, right? That's the preferred vector, right? So I've got this vector field here. That's the preferred vector flow. When you're in here, you see that things actually start sort of bifurcating, right? If you sort of, here you don't really notice either badge very much. If you somehow break the symmetry and end up over here, you find yourself drawn to this. You do more and more of that action. And of course, if you're really trying to get both badges, once you punch through this boundary, the main next goal is that one. Right? And the same thing happens symmetrically as you head this way. Right? So there really is this kind of steering effect going on. As you get near a badge, it pulls you, and now there are different badges competing for your attention. Yeah?
You've also assumed that the efforts of every step is about the same, that the users do not really have a huge choice in doing these types versus that type because these are easier than the others.
True. I mean, that could bleed into your preferred action distribution. Right? You might prefer this because it's easier. I haven't actually, so I would say easiness is sort of in the distribution because for whatever reason you have a distribution, you have one. But there is the time granularity. And I'll agree there that some actions take longer to do than others. And so you could view these as sort of bundles of activities, but that's one thing that we've been thinking about. So how do you put time granularity into it? I should mention that these examples are on very streamlined parameters, but you can sort of imagine that certain things here one can generalize for free, right? So for example, your preferred distribution could be different at every single state of the world. That wouldn't matter, because that's just a term here that I can evaluate. So it doesn't really matter. As you get older, as you mature, you have a different preferred mix. That's fine. That's no problem. And you can feel differently about one badge after you've received another badge. That's fine. So all of those are things, because this is a very expansive computation, right? It's doing the recursion at every single state, and so it can use parameters specific to that state. Okay, good. So let's ask. So we have this kind of pictures where things are sort of flowing and bifurcating. What, is that something where we really see that in the data? Okay, so let's go back to Stack Overflow and its badges that people covet. And let's talk about some cumulative badges in Stack Overflow. So we went and got data from Stack Overflow. Actually, most of this data is public. So there's a bunch of nice public Stack Overflow data that you can download. We actually got their help on a few things that weren't in the data that we needed. But here are two cumulative badges I'm going to focus on because they are axis-aligned badges, right? So when I say axis, I mean there's a particular action type, it just rewards those. One of them is what's called the civic duty badge, which is they want, right, Stack Overflow needs votes, right? Because the content is really curated by the collective voting. And so they need badges that reward voting. So the basic one is that you should vote at least 300 times and you will get the civic duty badge. That's a relative, about maybe 20,000 people have that badge. And that's a silver badge. So it's good, but it's not the best kind of badge. There's undervoting on questions. Because what happens is you read a question, you're engaged, you see an answer like, well, that answer is nonsense, and you downvote it, or you like it, right? So people are drawn to vote on answers. People have to sort of be reminded to vote on questions. And so they created the electorate badge to vote on at least 600 questions. There's a couple other technical conditions that I won't worry about here. But vote on at least 600 questions. That's a gold badge. That's rare. Only about 1,000 to 2,000 people have that, right? So that earns you the patch that you can wear on your clothing. So let me think about this in a five-dimensional action space, right? So the five things you can do are you can ask a question, you could answer a question, you could vote on a question, vote on an answer, or you could just go about the rest of your life. Okay, and let's ask. Let's go back to this picture and say, do we see the analog of this picture on Stack Overflow? So let's put. Good. Yeah.
Does voting come for free on Stack Overflow?
When you say free, what do you mean?
Like, do I have to spend a certain amount of karma to be able to vote?
Good question. So you can only downvote. So it costs you a little bit to downvote, and in the first initial phase of your life on Stack Overflow, you're barred from downvoting. And the problem was there were these denial of service attacks, basically, or so social denial of service attacks, where people wanted to target some user, so they'd register a whole bunch of accounts who each would downvote a couple times, right? So the idea was you have to actually prove you're in the system for a while before you start downloading. So there's some cost to it, a little bit, but not, once you're underway in the system, that tends to be viewed as noise, it would appear. Yeah. What's the question about this setup? So I'd like to put, the barrier out at 300 actions for civic duty, or 600 actions out for electorate. I'd like to count backward, how close are you to the badge? I'd like to see what fraction of your effort are you spending on this badge rewarded action, right? The badge favored action. Okay. And And actually, you can do this ordinally, like I did. It turns out it's sort of easier to see the picture if I do days. How many days are you? Well, I'll say day 0 is the day you received the badge. So I'll take everyone who ever received a civic duty badge, declare the day they received the badge to be day 0. I'll align them all there, and then I'll look at their aggregate fraction of different actions over time. And so here they are. So this is day 0 when you win the badge. This is question votes and answer votes as they approach the badge boundary. And you see roughly kind of what we were hoping to see when we looked at this, which is there's a ramping up which goes faster and faster toward day 0, and then sort of a snapback to roughly some base rate of activity. Right? So there's some mix of actions people are doing, both before and after. And I should mention that all of these users are people who had long histories afterwards, right? So the same step people are being averaged in over this whole year. There's some preferred mix of activities. Cumulatively in the population, it gets torqued by the badge, and dramatically so toward the end. Now, there's a bunch of things going on here. We're averaging a bunch of people, each of whom might have their own, P sub I, right? So if I is the individual, P sub I is their favorite action. So far, that hasn't come into play much, right? Because all this dynamic programming and everything, this was about one user. Right? And so one could certainly look at this separately for each individual user and think about what their optimization problem is. And I'm looking at some kind of average over all of them to smooth out the curve. The electorate badge produces an even more extreme effect, right? So here it is. You get this unbelievable cliff in question voting as you get here, which then drops back dramatically, right? So it's been climbing for a while here. We didn't extend the axis far enough out. Yeah?
Do we have an idea of how many users actually exhibit this effect? So for how many people is there like a statistically significant?
Yeah, it's a good question. So one way we addressed that was we built a hidden Markov model on user behavior and said the hidden states are roughly some coarsening of the probability of doing actions. And then we asked how many people exhibited a state transition in the vicinity. And it's a relatively large fraction exhibit, even if you set the prior probability in state transition to be fairly low. So it seems like under at least that quantification, some large fraction of people are actually doing some version of this. Yeah?
So the two problems appear slightly different, and then the first you seem to have a second order effect that you almost like train people to vote more, right?
Yeah.
Because subsequently it seems higher. So
Higher for a little while. Yeah, you train people, yeah.
I mean, so that gets to this question of, like, what is the role from the designer's point of view? Like, is there a sense where you can
The
get
badge
people is not just changing their behavior temporarily, but is there a sense that you can actually change their long-term behavior?
Yeah, which is a good question. So from a point of view of inferring these properties, that's a great question. That too could go into the model in that once you're beyond the badge boundary, your preferred mix of actions might change, and it might indeed be shifted. And so if you believe your badge has that property, that should go into the badge placement question. Yeah. So this kind of optimization model could certainly handle, once you've crossed a badge, you've added a certain delta to it. There are other things that are interesting, right? So I certainly think, right, you're not being trained here. And in part, you really get the sense that, like, voting on questions, not only do people not do it, the community really views it as like having to eat your vegetables. Like, they don't want to do it, and when they've done being rewarded, they're not. It snaps back. Whereas, yeah, the other stuff somehow is more in the workflow. The other funny thing, there was a thing here which I won't claim we understand, which is somehow suggestive, and which I sort of would love to come back and think about, which is, it seems to be a kind of mental categorization going on, right? So when you're in civic duty, you're spending more time voting. Where's that time coming from? It's not coming from asking questions. It's not really coming from answering questions. So it must be coming from just other stuff, right? What we call the life action. Although, granted, there's a couple other things on Stack Overflow maybe you're stealing from. But you're stealing from stuff not shown here. Here, you're not stealing from questions or answers. But when you're forced to vote more in questions to get the badge, you're stealing from voting on answers, right? That's what goes down. And so there's this interesting categorization effect where, and again, this is just looking at the data and trying to form interesting hypotheses. If, to the extent that people categorize voting as a single activity, then when they're forced to vote more in questions, they're stealing the time from other kinds of voting that they're doing, perhaps. I'll pose this again. It's a question, right? Why is this going down when that goes up, right? Is there some interesting sort of linkages going on between the different kinds of activities? Okay, so actually, right. So there's another way to, you can look at various visualizations of this, right? This is the fraction of question votes as you approach the badge boundary with heat map. It's all sort of roughly the same thing. Let me mention a different thing. I'll set this up before I actually go on to that slide. The one last thing, just a couple slides with a bit more math on them to say arbitrary badges, right? So in a sense, I've shown you two examples. I said, here's an axis-aligned 1D badge. Here's what you would do. Here's two different axis-aligned badges. Here's what you would do. And you sort of get the idea that you could sort of work your way down from the upper right. But naturally, you're sort of you should ask, so what does it look like in general? What does an arbitrary monotone badge look like? Okay. So arbitrary, and not just two-dimensional, right? An m-dimensional arbitrary monotone badge, a set of vectors that get you the badge, which is closed upward. And so the first question you should ask is, how do we even describe that, right? It's an arbitrary subset of this infinite space. It's all the places where you get the badge. And so to actually understand how to even describe it, we have to go back into some very elegant literature in combinatorics, which actually, if you've worked on computer algebra, for example, or Grosvenor bases, you've encountered this stuff, although it hasn't sort of leaked out into other parts of computer science as much. One way to describe a monotone set is using this thing called Dixon's lemma. So suppose I take all m tuples of natural numbers, okay, and I consider a set which is monotone, which means if something's in the set and I increase some of the coordinates, it's still in the set. Right? So it runs away up and to the right in m dimensions. Now the question is, how do I describe the boundary of that surface? The answer is that boundary actually has a finite, has a finite size description. There exists a finite set of minimal elements, so that the way to know if you're in the set is if you're at least as large as any one of those. Okay? That's what Dixon's lemma says. This is actually harder to prove than you think, or maybe you find it non-obvious and believe it's hard to prove. In some surveys about Dixon's lemma, it's described as the most rediscovered result in all of discrete mathematics, because lots of people encounter this and sort of not knowing how to search for it, they end up reproving it. But Dixon's lemma says we can describe a monotone badge in actually a very simple way, right? A monotone badge is something which has k different canonical action profiles, k different success stories of how you could get the badge. And you get the badge if and only if you've met the criteria for one of those k success stories. Right? That clearly is a monotone badge. It says you just have to hit one of those k success stories, one of those k minimal vectors. But the answer is that's all monotone badges. All monotone badges are describable by a finite set of success stories. And again, I would argue when you phrase it that way, it's maybe a little counterintuitive, but that is exactly the crux of Dixon's lemma. Okay, so using Dixon's lemma, we can actually describe an algorithm for arbitrary monotone badges. And again, this is more a kind of, I think, just to show that the issue is conceptually under control more than to suggest this is something that you would want to do computationally if you have high dimensions in an arbitrary monotone badge. But suppose I've enumerated all the minimal points of all the badges. Then I can roughly do what I did way back on, if I dare go back this far. Let's kind of recall this, right? This said, chop up space and start from here and work your way down. Once I've identified all the minimal points, I can sort of do that for an arbitrary badge. And again, think of this as n+1 dimensional. What I do is I draw a box that's big enough that it includes all the minimal points. So in a sense, all the hard stuff is now inside that box. The rest of it looks like a bunch of slabs of various dimensions extending out. And then the key fact is if you're outside this box, and you're at two different points where all they differ in is their big coordinates, right? So the things on this side are the small coordinates, things on this side are the big coordinates. If I'm out at a point where the only place where A and B differ is in coordinates that are beyond the wall of the box, then no set of future actions will ever distinguish them in terms of badges. As in, if I do any life history starting at A, and I look at the badges I got, that same life history glued onto B gets me exactly the same set of badges. Because I'm beyond all the minimal points, all the complexity. So it says A and B are now indistinguishable. They will have the same policy, and everything beyond them will have the same policy. So that's now way back in one dimension, we said we could collapse down stuff where it became irrelevant if you moved in that direction. That's what I'm going to do. I'm going to collapse everything down to sort of the skin of this box. And then I can actually just do induction on that, because now I've crunched everything down to a finite set. So that's the idea. Arbitrary monotone badge has this surprisingly finite descriptive complexity. Put a big box around all that complexity. Everything else, it's sort of equivalent as you go out that way, and so I just crunch it down to the wall of the box, and I work on that. Okay, and that's arbitrary monotone badges. All right, so one more set of issues. So placing badges, right? So the question for a designer, and I want to argue that what this sort of does, setting this up as an optimization framework, brings into play this notion that there is a badge placement problem. That if you have a badge, then rather than just sort of say, let's stick a badge here, you should actually think to yourself, where should I put it to get what I want? So here's a version of, and so we've looked at this, and actually one interesting test case that Dan, Jure, Ashton, and I have been doing is Coursera, for example, has a lot of milestones it wants people to reach. It hasn't made heavy use of badges yet, and so the question is, can we work with them and their data to actually say, where should you put badges? Right? And that's sort of an interesting test here because it brings into play all sorts of things about what can you infer from the action distributions people are doing. So that's work that's sort of just starting up. An abstract version of this question, right? A sort of mathematical formulation of this question is, suppose you're allowed to define a badge of value VB on a certain dimension, and you'd like to achieve an aggregate action distribution of Q. Where should you put the badge, right? People want to do P, you want them to do Q, you've got one badge to try achieving that with, right? Maybe you won't get all the way to Q, but you want to get as far as you can. And what's interesting is, you do get these interesting sort of interior optimum effects, as you would intuitively expect. So here, for example, we said, suppose we create a synthetic instance, again, just for pedagogical purposes here. Suppose you have a preferred action. I'm going to place a badge on type 1 to achieve the maximum number of type 1 actions I can over the whole population. Okay? And so, for example, in cyan here, this lowest curve is when people have they only want to spend 5% of their time doing action 1. And they're going to live for about 100 steps. Okay? And here I took a badge of value 200. And I said, OK, where should I put it? And the answer is there is this interior point. Right? It's far beyond the number they would normally do. But it's far enough out that you keep people engaged for a very long time and wanting to achieve the badge, because, again, you lose control of them once they're past the badge boundary. Right? Again, modulo, for example, Michael's interesting point about conditioning effects, which would be interesting to look at here. Right? And, of course, as people have more of a preference for doing the action on their own, where you optimally put the badge shifts out to the right, though less than you would think. It's relatively insensitive to how much you want to do that, right? If you have a very large reward on the badge. OK. The kind of vectors Q you can achieve is quite complicated. We drew this picture more to just emphasize it seems complicated. So this was, suppose I allow you 2 badges, each of value 200. And this is your preferred distribution of actions. You want to do 0.1 on action 1, 0.1 on action 2, and you want to get on with the rest of your life with 80% probability. Okay? So, and the question is, what are the feasible pairs, type 1 probability, type 2 probability, that I could achieve with 2 badges, each of value 200? Okay, so I'll put a dot every time I can achieve that with a badge. And here I was restricted to axis-aligned badges. So I can pick 2 axis-aligned ones here or there or whatever I do. OK. And these are the set of all feasible vectors. Right? So it reaches, and it's this weird kind of UFO shape. I don't know what it looks like, which says, it's certainly not convex, but it doesn't seem to have a simple description. So this question of what's feasibly achievable with badges seems like a hard problem. Right? There's a very hard landscape that I'm exploring. A couple things about the notation here. These are the things achievable with 2 badges axis aligned on type 1, 2 on type 2, and this is where there's 1 on each. And the darkness is really just kind of a mnemonic for this is the number of badge placements, number of distinct discrete badge placements that produce this feasible thing. But you can just think about the populated space as the actual thing that was achievable. OK. So let me actually just get a sense of time from. So wrapping up by about 1 is good. Is that whoever kind of think? Yeah, wrapping up by around 1. Okay. Going on. Good. Okay. So.
Do we get a badge for that?
If I finish by 1, then I get a badge. That's it. So good. So let me wrap up a couple questions here, and then also just spend a couple slides talking about how we've been thinking about sort of questions about competition, how badges derive value, and some other things that I think this connects to in some work I've also been doing with Sigal Oren. That was a couple slides. So a bunch of questions in this framework, and of course, I think it's always the case that when you try looking at something like badges and you try introducing a formal framework, as we did, there's an activity that consists of a kind of warping of reality where you try to get, the badge, which you had some intuitive visceral feel for, and try to shoehorn it into this framework. And, it fits partly, and you learn some things from it, and also doesn't fit right. And so that's sort of been the activity to try going from this, to this kind of picture. And, to the extent I've sort of helped try to warp your thinking on this so that you think about arrows lining up toward walls in some multidimensional space, I think that is a useful perspective for thinking about badges. And it's sort of interesting to think about where it works, where it breaks, right? So, I think it's reassuring to see that we do see these steering effects actually going on. One thing that's a very interesting open question is, where is the value of the badge coming from? And part of the issue is there are multiple things that it could be coming from, right? So, for example, it could be just your internal sense of achievement. You just feel good because you won this badge. You achieved a milestone you wanted to achieve. It could be social, right? That if I display the badge to others are impressed by me because I've achieved the badge. All of these are factors that come into it. You could think of other examples, right? That the badge unlocks features on the site, like I was mentioning, right? You can now do more because you have the badge. That's actually functional or transactional reason. So trying to build models of where these badges come from. The second thing is you're seeking out of badges, right? Badges are sort of a competition-free thing, right? The rarity might confer added status, but it's rare because it's hard to get, not because you beat someone else out. And how does competition work in this? And finally, sort of how far can we extend these analogies to offline domains, right? I mean, so like I spent lots of time when we were doing this. I kept because I'll admit I don't spend a lot of time trying to achieve hard to get badges on these websites. But in my life I maybe have other badges. So I thought about like, okay, this badge is you've done this is like research, this is teaching, and you're steering toward this and that, and there's tenure, and you can make up these analogies, and the extent do these analogies make any sense? And at some superficial level, perhaps not. But the question is there some deeper level? This is where I wanted to spend sort of a couple minutes. I think there is this interesting set of questions about how credit is allocated in scientific domains also. Right? And I think what's interesting is, when you actually look at how credit is allocated in scientific domains and the incentives it sets up, you see that there is a lot of actual central planning, right? You actually see that, people sit down, program committees sit down and say, what kind of work do we want to accept and what message will that send to the community? Right? When you're on an NSF panel, it often says, if we accept this work, it will send this message to the community. And so I think people actually do some amount of conferring of credit with a sense of the incentives and how they resonate. There are also sort of pathologies with these kinds of incentives, right? So, so two that have been discussed quite a bit. One is that certain research questions seem to receive an unfair amount of credit, right? That there are fads, that people work on some things and it gets heavily rewarded, even though other things that somehow seem equally important don't get rewarded. That's one kind of thing people might worry about. On the flip side, if I think about research as matching up people with projects, certain people get unfair amounts of credit, right? So Robert Merton's Matthew effect, right, is that if there's an independent or joint discovery between two people, often the more famous one gets more of the credit. It gets remembered as their result. It gets associated with their name. Robert Merton named it the Matthew effect, not because someone named Matthew was implicated in it, but because of the line from the book of Matthew in the New Testament of the Bible that basically says, they that have a lot shall get more, and they that don't have much will lose even that, right? And so this notion that the rich get richer. And so there's a question of where are these pathologies coming from? And and we can see how it plays back into questions of design, right? If I'm the badge designer and I put things in certain places, I've chosen in a sense to intentionally be unfair, to take people out of what they naturally want to do and steer them towards certain actions. And so there's a sort of implicit argument here that can sometimes be utility, in terms of the overall social welfare of the system, it could be enhancing. So that's a thing which my students Sigal Oren and I thought about in some past work. And I think one thing we're interested in doing is trying to unify these two things, right? Building on some work in the sociology of science, particularly some work of Philip Kitcher, creating an actual toy model of people choosing projects to work on, people competing with each other to be the first to do it and thereby get the credit. But then the community comes in and declares how much value to place on each of those projects, right? They say, if you solve this open problem, we will reward you this much in terms of fame, in terms of future, whatever. If you do this, we'll reward you this much. And asking, now I have a problem, how do I create rewards on the projects to get the outcome I want, that people will solve as many problems as possible? And the finding is that the optimal solution, as we saw with the badges, should generally allocate things out of proportion to what people want to do, but even worse, should often allocate things out of proportion to the true importance of these projects. Right? So if the welfare of society is being measured by the actual importance of what gets solved, what some of the work we've been doing here, and I won't have time to get into the technical details, is that it actually says you should create almost an artificial currency system, create rewards that are not simply proportional to the true rewards, but something else, and that will actually maximize the productivity. So I think there's interesting questions in this sort of crossover point between, when we think about badge designers creating systems, there's sort of this interesting thing to remember that we're creating these systems in our offline lives also, and even in sort of areas that are very close to our hearts. And I think some of the pathologies that we see sometimes are really sometimes, I'm not saying necessarily consciously designed. I certainly have not sat on an SF panel where people said, let's be intentionally unfair so as to do X. But people certainly do think through the consequences of what do we reward and what signals that send to the community. Right? I think all these are interesting questions. Okay. So that wraps up what I had to say here. Again, the sort of trade-off between badges as we see them in the world, badges as we see them in model systems, and really the different ways in which rewards can create incentives. And I think, as we look at these sort of different motivations, different ways badges derive value, trying to think about how those mixtures operate, right? This has been a very homogeneous picture of the world so far. But if I have a mixed population, some people are internal goal seekers, some people want, praise from others. How's it look when I have this mixed system and I'm trying to design a single badge for all of them? Other problems, right? There's kind of a long-range planning aspect to this. We haven't built competition into this. You're just trying to achieve the badge on your own. But when there is a leaderboard, how do you allocate your actions, knowing that others are allocating their actions? And there becomes sort of now a game being played, essentially. And finally, we've started to see that these effects are really present on sites like Stack Overflow, and we've now seen this on other websites that we've been working with. But this kind of estimation of these parameters, understanding is this really the right set of parameters, and how do we estimate them from the data is going to become an important problem, because as we try to turn this to an actual design problem and actually try to place badges, we're going to really need to understand exactly where the model extends and where it breaks. And so I think there can be a lot of questions going forward, really in sort of how these recognitions that we confer on people, both in the online world and the offline world, create incentives that steer our behavior. And I think that's going to lead to a lot of interesting questions going forward. Thanks very much. So do I take questions? Okay. Yeah.
So your data from Stack Overflow actually paint a pretty bleak picture. They show that the effects of badges are transient, and they only work for a short period of time just before receiving a badge.
The plot got cut off. I drew the plot at a certain distance out. Not clear. You see a ramp up for a fair amount of time up to the badge. It depends what a short amount of time means, right?
But yeah, after the badge, there's nothing.
After the badge, on all of these, there's nothing, right?
So do you envision a world in which we basically have to have a continuous army of badges one after another, and that's the only thing that keeps people doing interesting things more than they would otherwise do?
Good question. So a couple comments. So first of all, I think it's interesting to taxonomize badges into the ones that are transient and the ones that aren't. And I think this point, for example, that this is consistently higher than it was before you got the badge.
Well, probably because they are beginning to shoot for electorate, right? So only the green line is higher.
You don't get an electorate for voting on answers. Questions, they're probably shooting for electorate. Answers, you could argue whether it's higher or whether it's going
Answer is going back to the
You could debate this.
Along those lines, when you're talking about this, you were talking about Stack Overflow, but what came to my mind was things that have been around for years, which is the airline frequent flyer schemes, where there's clearly what the incentives are, and like you say, they make those badges transient, right? They expire every year, and you have the same sort of, I think, very motivating effects, right? As you get close to the boundary, they're trying to incentivize you to take more flights with them as opposed to other carriers.
No, obviously, as you near loyalty program boundaries, you get these extreme things. So like on Flyer Talk Forum, there's the what are good mileage runs where you just need 500 more miles to get gold status. Exactly. But yeah, so are they transient? Are we going to have to? So I think it's interesting, sort of, are there any badges that condition people to behave differently after you get them? Interesting question. But yeah, I think, it's not necessarily, you don't have to keep necessarily making up new badges, but having expiration, having periodic badges, right? Badges that persist forever. But the other thing to remember is a lot of these people are here, they don't get any of these badges, right? There is a lot of activity on Stack Overflow that is unbadged activity, right? So I think of a badge not as the reason people are there, but as an enhancer, right? This activity is going on. It's going on in a certain way that it would happen in the absence of these things. These things are now being set up to try getting a little more out of the system. But so I think, the bleakness, the fact that these lines aren't all zero means something is happening, I think. Even in the present value. So yeah, I think it's a mixed picture. Question.
So we can think of your model at a couple different levels of generality. And one is taking the badges very literally as things of pure social value, and that's important for some things. Another thing is it's just threshold-based rewards. Forget where they came from. It could be money, it could be whatever.
Yeah.
And this fact that you invest quicker near the boundary for discounting is completely standard in investment problems. It'll be very general in a wide set of domains, including, you mentioned extending this to gains. So there's a literature in economics on patent races, and patents are also a threshold problem. And this question of where to put the thresholds for patents is very important. And maybe you could take some of this machinery and look at optimal patent rules and how big an increment should this innovation be to get a patent and things like that. So that's a related domain of wouldn't call them badges, I call them threshold incentives or something.
Yeah, no, that's a very good point. And yeah, looking at those connections would be great. Yeah, David.
So one of the things that I'm kind of curious about here, which you've alluded to, is when we begin to think about the value of a badge, maybe depending on how rare the badge is and how many other people have the badge, kind of very fascinating thinking about the next variation on your model where you're putting the badges down, kind of thinking about the equilibrium effects of now as other people are moved towards that badge, then how many of the people are going to get the badge? What is the value I might have now getting that badge? Have you started to think about that type of thing yet?
We've talked a little bit because as you're observing, it occupies this intriguing middle ground between competition and lack of competition. As in, competition would say, I am restricting the only one, only K people can get this badge. And so then there's now this. No competition means there's not even any value conferred by it being frequent or rare. This is somehow saying, right, in equilibrium, your belief behind people will get the badge creates a value that you infer to it, and that drives your behavior, and at equilibrium, the behavior you get will get exactly that many people getting the badge, right? And yeah, so that's sort of, it's not competition, but it's something else that the rarity somehow becomes part of the model. Yeah, we've talked a bit about that and how that would evolve, because it's a more subtle, more interesting thing than just saying I put a hard limit on how many people can get this thing. Yeah, great question.
Do you ever find situations where badges dissuade people? Like, you don't want to tip a doctor or something because it makes it seem cheesy or something?
Good question. We haven't, right, so just waiting for, so we haven't seen exactly that, where like you put the badge in and stuff doesn't happen. It's complicated because there are so many badges here that when you see a decrease in activity, it's often activities being offloaded from this because there's some other badge that's happening, right? And so, the thing about the badges as a whole system involves this kind of rebalancing of things. But yeah, it's a very interesting question whether you could get negative effects. You can also imagine non-monotone badges where you want to do, the electorate badge, you want to get the badge, but you don't want to be sort of...
No, I'm just saying the mere presence of a badge makes something seem like a game when it's actually something very serious.
Yeah. One would have to think about the right site for looking at that. One thinks about it in education context, right? Sort of, the sort of benefits and maybe pitfalls of turning this into a game with levels and so forth. Yeah, we haven't seen this in the sites we've looked at, but yeah, very good question. Yeah.
So it's very interesting, extremely interesting, and I think you have also an answer to another question that I was trying to grapple with, which is, what if the two types of actions you have are of different difficulty, and when you consider them equally, and I will take my favorite example that has to do with tenure. There you don't have two badges, you have one, which is kind of diagonally, and you may have journals and conferences. Yeah. Well, with your system of looking at the more common paths, you could see what community is doing eventually. You would probably see more towards conferences, which might help CFA committees to figure out an algorithm to adjust according to the perceived, level of difficulty between the two venues.
No, it's an interesting question. I think this crossover into the academic world is very interesting because, in some sense we're talking about sort of life trajectories here. And what's nice with scientific data is it's very finely measured things that involve career trajectories, right? So there's your whole publishing history, there were certain career milestones. And you could ask, do we see in aggregate a shift of activities as you approach certain career milestones? And then that's really one thing we thought about is sort of we explore this crossover between some of these models and then into sort of data on scientific production. Yeah, totally. Yeah.
I'm curious, what sort of cost functions, did you try, and what really worked?
Oh, yeah, good question. So, right. So, we're sort of in the formation of the model, we just said, it's a monotone, sometimes monotone convex cost function because you're subtracting it, so it becomes concave. In the sort of toy examples I drew for pedagogical illustration, we tended to use quadratic functions, although anything that sort of was convex and became concave when you negate it produced similar kinds of qualitative effects, as in the kind of same interior optima, the same shifts as you increase the badge value. We're sort of at the cusp of asking, what does seem to be the inferred pain people feel when they deviate from their preferred distribution, right? And so that's a question where one starts to look at, if I believe this badge has some value and you're discounting as you go in the future, then I should be able to infer what it was that how you were evaluating the offloading from this. It still seems open. There appears to be sort of a sort of flat region around the preferred activity where you don't notice small deviations. And so probably something resembling convexity is probably present. But yeah, we haven't really pinned down functional forms. Yeah.
Is there any evidence that this increased number of actions is somehow decreasing the quality of those actions?
Yeah, excellent question. Yeah. So that one, because there's a lot of anecdotal evidence that, when someone's about to become a top 100 reviewer on Amazon, they suddenly go on a spree of writing forward reviews, and then they get the top 100 badge. And then, of course, they need to preserve the top 100 badge because there's this transience problem, and so they often keep. And so, if you see someone who's a top K reviewer for a very small K, you should worry about. So we looked at a couple things. So we looked at, for example, so there's a nice quality signal here, which is upvotes on your answers. You're doing answers. So answers weren't being rewarded in either of those. So we looked at other milestones. So for example, just the reputation system on Stack Overflow, the bulk of the reputation comes from answering questions. And there was not a big change as you approach rep milestones. So the 1,000 reputation points, 2,000 reputation points, which was slightly surprising to us. Of course, there's some feedback thing here because you're getting rep by getting upvoted, and so.
Yeah, that was going to be my question. Reputation points and number of answers are not the same here, right?
Right, but if people are making the calculation that by answering fast, I'm going to get sort of the base rate of rep increase, and I'm going to trade it. But people didn't seem to be doing that calculation. They somehow wanted to get the upvotes. We looked at, are people using sort of tricks to get to the voting? Right, if I wanted to vote on a bunch of things really fast, I probably am going to have a hard time maintaining my usual distribution of positive negative, because positive negative implies some evaluation. The fast way to vote really fast would be to either, just vote positive on everything. The balance of voting also didn't seem to change very much. People seem to use their same mix of positive negative as they approach the badge. So I think there are clearly domains where that's happening. That does not seem to be happening here. Yeah.
You can copy a successful badger behavior and so go under the radar.
As in just copy whatever they did.
Yeah.
Except the votes are expressed as numbers. So unless you work hard, which would take even longer, you'd have to actually go and see how did they vote. Yeah.
Write the program.
You're right. There does not seem to have been that problem with Stack Overflow thus far. Yeah.
I'm not sure about metrics for this, but you're trying to figure out why people are trying to get a badge. Have you thought about visibility of the badge? I mean, if I'm the only one that can see it, do I still want it as much as if the whole world can see it, or is it?
So we want to do some randomized experiments. So with some of the sites we're talking to, we somehow want to do some form of randomization where you say, some people you can see it. I mean, it's tricky how to do this without really irritating the user community because, hey, why did they get to see my badge? So we're working on that kind. But yeah, this issue of visibility and not visibility. Currently, it's sort of cross-domain, but then it's very hard to compare across domains. So yeah, I realize I haven't been looking left. So yeah.
If you go to the more gamey approach to the problem, it seems that another component that would be interesting to look at is the underlying social network. So right now you're modeling everything as everybody is connected to everybody, like a huge community, but really in the real life, there is some social network, and my value from a badge is really coming from my place in my social network, and both in the design, from the perspective of the design, and from the perspective of how I derive my value.
Yeah. No, we've been hoping to look at some of that. I mean, so for example, in Coursera, where there could be study groups, for example, do you sort of care more about sort of what people are doing in each study group? Stack Overflow, you have a little bit of that because there are people commenting on each other's posts, but there's less of a stable social network there. But yeah, I think that's a very good question in the long run, that to the extent badges have social value because they confer status, do I care about the status at short ranges, like the people who are connected to me, or do I care about status somehow and globally, and can I somehow separate those effects? Yeah, very much so. Yeah.
So many of these sites also have a continuous reward system, like points, number of posts.
Yeah.
Do you model that at all or study that at all?
Right. Good question. So we haven't looked at sort of the continuous. I mean, so the reputation system is one, right? Yeah. There's a kind of continuous allocation credit. That has. So here we've really looked at the kind of cumulative effort badges. Even continuous reward systems often are sort of then have milestones at certain points, right? So like the reputation system is continuously allocated, but then it also confers certain things.
But it just seems like a way to get around this, this big jump that you have just by being a continuous.
Yes. I mean, the interesting trade-off is, of course, right. If you want to get sustained activities, you reward people sort of continuously for it. And so it's interesting to sort of ask, what is the benefit? Obviously sites have gravitated toward these milestones. What is that doing rather than just, essentially what you're describing is almost a wage scheme. You put in a certain amount of time, you get a certain wage in terms of reputation or whatever. So I think it's interesting to ask sort of what's a model of user behavior such that getting big rewards discretely is somehow having an effect that paying a continuous wage wouldn't.
What if instead of rewarding one more question?
Okay.
What if instead of rewarding total number of actions, you look at the rate of actions, or else right after achieving a milestone, give rewards for sustained continued achievement right afterwards, or something like that?
Interesting question. Yeah, it'd be interesting to try building up a model of that. The technical condition on the electorate badge was trying to do a little bit of that. So it said you need to do 600 question votes, and question votes have to be sort of at least 25% of all your voting activity. So there's a way you could end up getting 600 and not having met that condition, and that sort of is a rate condition relative to another action. So not wall clock time, but relative to other. Most people, that condition never becomes binding. So if you take all that out, if you take out people who are affected by that, nothing really changes. But yeah, it's sort of a hint at, right, you could talk about you should do this and you should do it at a rate that's commensurate with other rates that you have on the system. And we haven't thought yet sort of much about how to model that, but that's sort of latent in some of this data. Great. Thanks again.